We are going to discuss what are Python modules, why do we need to use them, what are the different types of Python modules, and how differently, in different ways, we can import these modules in our code. Now, a Python module is nothing but a simple Python file with .py extension, including the statements and the definitions. So basically, you need to prepare a module file with all the functions which you want to import into your regular Python code across all the modules. Now it contains codes that you can reuse in several programs. So it's like saying you write once a piece of code like common utility methods, calculation methods, rounding off, addition, subtractions, or some common business rules which can be reused across your project. Then you keep it at one place. Now this helps in such a scenario where you have a large team, different set of developers are working on different modules, different specifications, but one single utility module file .py file will contains all the common and reusable functions which not each and every individual developer can will go and change. It's only few set of administrators or the senior developers can maintain and pass it on to the team. Now, for example, a file containing Python code demo.py will be called as a module, and its module name would be demo. So you need to take care that whatever the name of the file is, that is what will get imported in your Python code. So we will see that with our certain examples on our Jupyter notebook. Now, why do we need to use, as I have reiterated, it provides flexibility to organize the code in a logical way, and it enables reusability, which is the most important factor. So one, of course, you can organize the code, you keep the reusable code at one place, or you can keep a modular approach and also reusable. So not all the developers have to go and rewrite that code, and it is easy to maintain and helps in debugging the code easily. So if you know that there is an error coming, there is an issue coming in one of the modules which is imported or which is lying in the common file, then it becomes easy to debug. You just have to go and check that particular function. You don't need to go and check in each and every piece of code. Now there are two types of Python modules. Definitely there are built-in modules which Python library provides, which you don't need to import explicitly. But there are certain user-defined modules which you create on yourself for your own custom development, for your own custom programming. So built-in modules are predefined modules and are part of the Python standard library. For example, random, datetime, sys. So we will take a look at these examples also. And of course, the user-defined modules, which is the primary objective of this session, where we're going to show you how do you create your own defined modules and then import them. So the user creates the user-defined modules to ease complex tasks in a project. So you program the complex piece of the code in a common module and give it to everyone. You can define your own functions and classes. Now, what are the different ways? There are 5 different ways you can import modules. So you can just say import module name, and all the classes and functions within that module will get imported. You can give an alias. So basically giving an alias makes it simple, and you can refer that alias throughout your code. Then if you want to import anything specific from the entire module, you don't want to import all the functions and classes, then you can just import the specific functions and classes and give their name. Then fourth is from module, you want to import any address as an alias. You can import and give an alias to the specific function name or the class name. And then of course, similar to the first syntax, you can module everything. So first and the last syntax are almost having the same meaning to import everything in your module. Okay, so with this background, let's first take a look at the Python file. So what we have done is we have created a module calculations.py. So just please focus on the part where the name of the file is calculations. And in this Python file .py file, we have created a couple of functions and the relevant logic related to those functions. So very simple functions like addition, add, you pass two variables and you send the result, add the variables and send it back. Basically, we are overriding the Python internal operator add in our Python module, and we will be invoking this one. So we'll show you how to invoke. Then you will have, I have written multiplication, division, remainder. So you pass two variables, divide them and find the remainder. Then now a custom function where I'm adding 10 to both the variables which are being passed to this function and returning the result. Then there is a function which checks whether the number is a prime, and if it is not a prime number, you will get this output, and if it is, you will get a prime number. Okay. And then another function which says check anagram. So we will just sort the two strings which we will send and check both are equal or not. If both are equal, then the strings are anagrams, otherwise they are not. So these are the set of functions which we have written. Now we will see how will we use them in our code. Now, first syntax which I am writing is import calculations. So this is the name of my .py file which is residing in the same folder where I am writing this piece of code. And now, if you see in my .py, I have a variable y whose value is 6. So I'm just using that value and running it and printing it. I'm just going to show you how explicitly I'm invoking the functions in the calculations class in the calculations.py file. Okay. Now let's invoke another function remainder passing 140, and then I should get 20 as an output. Okay, so this has gone back and executed this particular function. Now what I'm going to do is another example of my addition. I'm saying calculations.add. I'm going to initialize and pass two variables, and my expected output is 35. Okay, so it has gone and executed this function. Now I'm going to show you another syntax of importing. So from calculations, I'm just importing the add function. So I'll ask for user input to enter for 1 and 2 numbers, and then I'm just going to add it. 2 and 5. So I got my output as 7. Now the difference to be noted over here is that in the previous syntax I was making a call like calculations.add, but now I don't need to make a calculations.add syntax invocation. I just need to say import add, and I just need to use the add function. That's all. Now let's use another syntax to import modules. So I'm using import calculations as cal. So all the modules are imported, but the alias uses cal. And similarly, like the previous example, I'm going to take two inputs and print the sum. Now the difference in this syntax and this syntax is I'm using the alias cal dot add, but my output should be same. Okay. Similarly, I can call prime, whether it's not a prime or prime number. I can call the check anagram using the same alias, and I can call the remainder function. Okay. So I hope you have noticed that the difference in importing, the way of importing the module makes a lot of difference, right? Now let's take another example of importing some functions or variables. So I'm going to explicitly, I'm importing my variable y and functions multi, prime and check anagram explicitly. And I'm going to print y. Okay. And I'm going to multiply two numbers. So if you see, I'm using these aliases over here. Okay. I'm using these variables directly as I've already imported. Now I'm going to say prime 9. Now it's printing none. If you see, it's because of the statements which are not executed, right? So that's why you are seeing. Now let's check anagram. And now another thing to be noted is I'm trying to invoke a function remainder, which I have not imported over here. So let's see what error Python throws. Okay. So yeah, so Python has throws an error that name remainder is not defined because I have not imported it over here. So now in order to import remainder, what I'm now doing different is importing all the functions. Now if I use remainder, it should run. Okay. I'm using divide. Okay, cool. Now I'm going to show you another function, which is a utility function, directory function, which will show me all the functions, variables as part of the Python file: add 10, check anagram, divide, multi, prime, remainder, y. And of course, these are some inbuilt packages which are already there in the Python file as part of the Python loader. But these are the ones which I have created. So you can actually see the list of all those functions in one go. Okay. Now I'm going to show you an example of inbuilt modules. So this import math is an inbuilt module of Python, and I'm going to show you how you can see all the relevant functions within the math module. All these are the math module functions which are available for you to use. I'm going to show you one or two. So like print math 2 to the power 8 and you get the answer 256. Print math remainder. So I'm not invoking my module function. I'm invoking the math inbuilt library function remainder, and the remainder is 0. 40 divided by 2, remainder is 0. And square root of 81, 9. Then very important, another very interesting utilities of date time, which you can use, and you can print today's date and time. Then another utility is random utility, and I'm going to create a list L1 and write a piece of code which will choose a random element from this list and just print it. Okay, so if first time it has chosen Oppo, again if I run it, it will choose OnePlus. If I again run it, it might choose something else, so it will randomly pick. Okay. Okay, so with this, we have seen that you can create your own utility functions, import it, write it in a piece of code, .py file, import it in your code as an alias or all the modules and use them, or you can use the Python inbuilt modules, right? Today, let's quickly take a glance. We're going to talk about map function, filter function, and reduce function. We're going to see the syntax which are applicable to these functions and what benefits these functions bring for us during the programming in Python. So we're going to see the syntax and we are going to run certain examples for each of these functions. So let me first just give you a brief of what are the syntax for these functions, what are the signatures, what are the input parameters required, and then we will jump into the Jupyter notebook and run some
examples. So what is a map function? The map function takes another function as an input, and the second input is a sequence of iterables. It could be a list, it could be a set, it could be an array or anything you want. And it returns the output after executing the function which you have passed as a parameter on each of the element of that iterable. So the function could add the values, could multiply, could divide, or any mathematical operation you want to do, or even you can perform certain string operations, which we will take a look in the examples. But the idea is that you want to apply the function on each and every iterable item individually. So the map function helps you achieve that. Also in our examples, we will take a look that you don't need to explicitly define a function. You can also use lambda functions, which are inline functions. So you don't need to increase the line of code. You can reduce the lines of code by just writing the function in line, and that way it will make it more simple. The next function which we are going to talk about is the filter function. Now, what is the purpose? The purpose of the filter function is to reduce the size of the iterables based on the condition which you will pass to the filter function. So syntactically, it is very similar to map function, but the only difference is that you need to pass a function which carries a condition. For example, you have a set of iterables 1, 2, 3, 4, 5, 6, 7, 8, 9, and you want the function to return values which are greater than 5. So your filter function should have a condition which says that the iterables greater than 5 should only be returned by this function. So that's why you have to make sure that a filter function always have a condition which is either true or false. So based on whatever condition matches as true, the filter function will only return those values as an output. So we will take a look. And the same concept applies. Either you can make a explicit function or you can apply lambda function inline. The third function which we are going to talk about is the reduce function. The only difference between reduce function and the other functions which we talked about, the map and filter, is that reduce function always returns a single value. So it combines all the values in the iterable, your list, your array, your set, and returns a single value. So you can apply the mathematical functions, like for example, you want to add all the values in your iterable, or you want to multiply. So it will multiply sequentially and give you the output. And the same concept applies over here. You can have lambda functions or explicit functions. Also, with one thing which you need to remember is that you need to use function tools module to import the reduce function. So we will take a look at that while we will be running certain examples. Okay, so here we are. So we will start by running our examples. So first we will start with map. So let's start by defining a very simple function which adds two values, right, and returns you the added value, right? So in the next step, we will define a list of iterables. So here we have taken an iterable list of 4 items, 4, 6, 8, 9 numbers. Now in this step, we will apply the map function. Now please notice that we are sending two parameters to this map function. One is the function name, which is add, and the list, which is numbers. Okay, now I'll print the out, but it's an object, so right, it's not in a readable format, so I need to convert the out object back to a list. And now I'll be able to print And here is my expected output. So I had four numbers in my list, which is 4, 6, 8, 9, and the map function has added the numbers to itself: 4 plus 4, 6 plus 6, 8 plus 8, 9 plus 9. And so that's how you're getting the output as expected. Now let's take a look at another example. We're going to redefine our list, and we are going to use now a lambda function instead of an explicit function, which is going to multiply the numbers in my list with themselves. And we're going to print my out object, convert it back to a list, and then I'll print my converted list object. And here you go. This is my output: 4 multiplied by 4, 6 multiplied by 6, 8 multiplied by 8, and 9 multiplied by 9. Okay, so here in this example, we have seen about lambda function. Now, we have been performing mathematical operation. As I mentioned earlier, we can also perform certain string operations. So let's take an example. What I'm doing in this example is I'm creating a map, and I'm just converting all my lowercase strings to uppercase, and I'm just printing my list now after conversion. So such kind of string operations are also possible. Let's take another example where we are going to print the length of each of the string which is there in my list, and I'm using lambda function. And here it is. So now you can see the list, the length of each and every string variable in my list: 3, 5, 6, and 7. Okay, so now these were the examples of map object, map function. Now we will talk about filter. So let's start with a simple example. So as I mentioned, the filter function should always have a condition. So let's create a function which has a condition saying if a is greater than 5, then return a. It means that you need to only return numbers which are greater than 5 in my list. So now I'm going to call this in my filter function. So if you see the syntax here, please notice filter, you pass the fill and the list, and then you print the out object after converting into the list, and only the numbers which are greater than 5 are printed. Now let's take a look at a lambda function example rather than an explicit function. The same example, but now instead I am using a lambda function, and I'm going to print it. Output should be the same. Okay, so the only change is in the syntax of the function definition. Here we have explicit function, and here we have a lambda function. Output is the same. Now let's take an example of a string operation, string filter. What kind of string filtering we can do? So I have an example over here. So what I'm going to do is I'm going to have a list of string arrays which is going to return me only those strings which have E in them, occurrence of E. Okay. So I've created a function veggies with E, and within this list of veggies, peas, garlic, ginger, beetroot, carrot, I will only get those string variable values which have E in it. Okay, so I've got the result: peas, ginger, and beetroot, right? And garlic and carrot have been discarded. Now let's run this similar example with lambda function. where I'm saying that, okay, give me those vegetables which have R in it. So I'm just gonna run this and print my map. Okay, and here is my expected output: garlic, ginger, beetroot, and carrot. So what have we noticed is that similar to map filter function, of course, the only difference is the function should have a condition which should return a true or false, and based on that, the iterable list get filters out. Now, let's talk about reduce. Now, as I mentioned, the first important thing is that we import the reduce function from function tools, okay, and then we apply a lambda function. So we're going to start off with just taking an example of lambda. So here is my list of 4 elements: 10, 35, 50, and 20, and I'm adding the numbers in this list. Okay, so the map function is not gonna, the reduce function is not gonna add the numbers to itself, but to the subsequent number in the list, right? So what is the expected output, right? The expected output is 10 plus 35, 45, plus 50, 95, plus 20, 115. So what the reduce function has done is it has added the numbers in the list amongst themselves, right, in the orderly fashion. Now let's take another example. Instead of addition, we'll do a multiplication. Okay. So here what we have done is we have multiplied 9 by into 7 into 23 into 4, and we've got this answer. So this is another way of doing it. Now instead of lambda function, I'm just going to show you a simple adding the numbers. I define a function where you add the first and second number, and then you pass the function name to reduce. So custom sum and the list, similar to what we had done for map and filter, and now you can print the result. Now one thing to notice is that this result is a single number. You don't need to convert it back to a list, so you don't need to do that transformation. You just simply print the result, and here it is: 68. 3 plus 4 plus 6 plus 9 plus 34 plus 12. Okay,
We are going to start with discussion of need of exception handling. What is exception handling? The types of errors you can handle in exception handling, and how exception handling works, and in the end, certain points to be remembered. And also we will support our slides with a Python Jupyter notebook examples. Now, what is the need for exception handling? Any programming language or any program you write, there is definitely a need in order to have a clean execution of the program, even if the program throws errors. So you need exception handling for cleanly logging the exceptions or throwing meaningful errors to the users. So when does exception occurs, right? Whenever the program gets terminated, right? The program terminates whenever an error occurs, right? So it could happen that an error could be a fatal error and the program gets terminated in between, or there could be a sudden termination which can corrupt the program, right? So you need to handle exceptions, or there might be a data loss because of those exceptions, and you need to take care that that doesn't occur, or the data loss does not happen. Or even if data loss happens, then you pass on a meaningful message, or you capture a meaningful message in the logs at the right point. Now, what is exception handling? An exception is a runtime error that terminates the execution of a program. So basically, whenever an exception occurs, the program gets terminated, you are thrown out of the running program. Exception handling means you generate a message in correspondence to the occurrence of the error and take the right step to handle it. So now an exception has occurred, but you need to handle it. Now, by handling, we mean that you need to throw a meaningful message, as I said earlier, and then you might need to navigate the program into the right direction or take some certain corrective actions in order to handle the error. So, all that comes under the exception handling criteria. Now, in general, there are three types of errors: compile time errors, logical errors, and runtime errors. Now, compile time errors are the errors which any programming compiler or Python compiler will show you while you are compiling your program. So, it could be because of the syntax, spacing, indentation, or you are using wrong keywords. All those will get captured at the compile time. Logical errors, you have not used the correct syntax around logical operators like and or your if else conditions are incorrect and you are expecting an output, but it is not coming as per your expectations. So those are logical errors. And the most difficult ones to capture and track and handle are the runtime errors. So imagine your program is compiled and as per your expectation, you are expecting an output, you have written a logic, but at the runtime it does not get executed, it does not run as per your expectation, and the program gets terminated unexpectedly. So the runtime errors are the most critical and important in order to handle them. And if you talk about runtime errors handling in production scenarios, then it becomes very critical that you have handled the exceptions correctly and captured the logs correctly so that the team can point out where the error has exactly happened. Now, how exception handling works. There are certain syntaxes in Python which you need to follow. Now, you generally put the exception handling code, the code for which you want to handle the exception under a try block. So you run that piece of code under a try block, and then you put an except keyword where you basically throw an error message, and then if there is no exception, right, then also you can handle the code. Okay, if there is no exception in my code, then how the code will behave, yeah, right? So it could be possible that there is a runtime error, but if there is no, then you might want to do some logical calculations, or you want to put something over there, you can put in the else block. And then finally is a code block which will always get executed irrespective of you had an exception in your code or not. So basically, generally, if you go by the legacy programming, if you have opened a database connection, or if you have opened a file and it is essential to close those connections from your program, then those close connection code are written generally in the finally block, irrespective of the exception coming. You need to close those connections, otherwise you will run out of your connection pools. Now it's a pretty straightforward flowchart of an exception and handling. You start with a try block, and then if an exception occurs in your code, then it will go to the except block. Otherwise, it will go in the else section. And then finally, you have the finally block where the code will finally get executed and stop. So as I said, you put that piece of code in the finally block, which is mandatory, and generally the code which is essential to release the resources which the program has consumed, the CPU resources, the memory resources, hardware resources which the program is using, you have to release that in the finally block. Except block you have to use for capturing the error and throw a meaningful message or do any other logical operation, and else block if you want to continue your program as is. Now, what are the points to remember? These are very important points which you should consider. You can write a try block without any except block. So it's not essential that you put a except block always, or you can write several except blocks for a single try. You might be expecting a null pointer exception or a divide by zero exception, or incorrect variable naming exception. So you can start off with one try, but you can have different except blocks to capture these different kind of exceptions and throw a relevant meaningful error per except block. Also, you can write multiple except blocks to handle multiple exceptions. It's almost the same thing. And you can write exception as an object. You can also print or capture an exception as an object, or you can write multiple exceptions within a tuple. You can capture the multiple exceptions, add it to a tuple, and throw it away. Okay, so now let's take a look at certain examples which we want to run in order for better understanding of exception handling. Now, throughout my exercise, I am going to focus on divide by zero error, which we are easily able to simulate. So I'm going to mostly show you how we can capture a divide by zero error. Okay, so I have declared a variable a and I have declared a variable b, a as 10, b as 0. Now I'm trying to divide a by b. Now I'm trying to divide a number with 0. So ideally, yes, this is not a correct mathematical operation. Divide by number 0 is not allowed. So I should get a zero division error. Now, this is an unhandled exception. My program has not handled it properly, so that's why you're getting this error on the trace of the Python trace. But if I handle it properly, then I can very cleanly throw this error and capture this error. Okay, so I am going to take input in B, enter A and B, and I'm just going to print a generic except block. So 10, 0, and I have got an exception and I've printed it. Now there is no stack trace, there is no trace, but at least I'm able to cleanly throw an error, a meaningful error. Now again, I'm differently going to handle the exception. I'm going to create the same exception, but going to handle it differently. Now there's a try block. Now I am writing an except block to capture the specific exception, zero division error exception. In the earlier code block, I had just written except, so any exception would have come to this block. But in this except block, only zero division error will be captured. So as you can see, I cleanly handled the exception. Of course, I gave the name except zero division error, and then my code got executed later on. Now, in another example, what I'm going to do is I'm going to show you that if my code runs cleanly, then it's not necessary my except block will get executed. Definitely, because if there is no error, then the except block will remain redundant. Now here you see what I have done is I've taken genuine two numbers, divided them, printed a new line, and then completed. So as there was no exception, the exception block did not got executed. So the point to be highlighted over here is that it is not essential that exception block will get executed always. It will only come into picture when there is a relevant exception getting generated. Now let's take an example of how we can print an exception object. So I'm going to take my previous code, and here I am capturing the exception but also printing the exception object. So what has happened is I have printed the exception of a message, a custom message, plus I have printed the exception object. Okay. Now I'm going to take the same example, but I'm not going to generate an exception. So my exception block did not got executed, and I was able to simply print Simplilearn. Now let's take another example where I am capturing my exception in a variable. So do not divide number by 0, and in this I have captured my exception division by 0. So in the exception, the Python generated exception name is this, and I have printed over here. So division by 0 is the Python generated exception which I have appended in the print command. Now I'm going to take another example where I'm saying is that I will print exception as A, plus I'm going to also capture another exception. So it's like one try and two exceptions. So one exception is do not divide number by 0, and second exception is name Z is not defined, right? So as I said earlier, you can have one try but two except blocks, which is permissible. Now one thing is that this exception print A by Z went through both the except blocks, except this exception and this exception, though this exception is not divide by 0 error. So therefore in this A variable nothing came in, but in the B variable the name error was definitely captured because it's a name undefined, name Z is not defined error, and that's why you can see that do not divide number by 0. After that we do not have any relevant meaningful message. Okay, now let's take another example where we are going to have two except blocks, and out of these two only one will get executed. Okay, so there is no type error exception, so that except block did not got executed, but only 0 division error is there, so only that got printed. Now you can explicitly also raise an exception. It's not like you just have to wait for a runtime exception. You can also raise an exception from your code and execute it. So if you see this, what we have done is just created a variable with a negative value and just checking that if the value is less than 0, then raise an exception. So that's what we have done. Similarly, you can also raise an assertion error. It is called assert, and you can run this message. You can throw this message compatible with Linux only. We will understand what is file handling. We will go through certain file handling operations. Then we will understand how to open a file in Python using various modes, which are pretty important. And then we will discuss the file handling process, the different types of files which we can create, and advantages of using files.
Now, what is file handling? A file contains a collection of data and information. It is just like a data storage. So the data can be updated and shared through files with multiple stakeholders. Now, file handling in Python performs functions such as creating, reading, updating, and deleting. So you can perform the basic CRUD operations using the file handling functions and operators. Now, in Python, file operation takes place in the following order. In order to work on a file, you have to first open a file. That is the first and foremost step. And then you can perform any read or write operation. And then you have to close the file. So these three primary steps are involved in order to do any operation on a file. Now in Python, we can work with files using the open function, and it takes two parameters, the file name and the mode. So here you can see the syntax. If you do not give the mode parameter, then it takes the default values, which we're going to see in our next slide. But at least you need to give the name of the file with the extension. Now, what are the various modes in which you can perform operations on a file? Let's go through them one by one. You can open a file, first of all, in the read mode, which is the default mode, and it opens a file for reading. But if the file does not exist, it throws an error, right? Second is append A. It opens a file for appending, creates the file if it does not exist. So in this mode, if the file does not exist, it gets created. Similarly, in the write operation, it opens a file for writing and creates the file if it does not exist. So A and W will create the file. X, it creates specified file, returns an error if the file exists. So you cannot create an already existing file, you need to give a different name. Then the next mode is the T mode, the text mode, which is the default value. So by default, when you open a file in Python, you are basically opening it in default read text mode. And the next mode is the binary mode. If you specify B, it means that you're trying to open an image or any binary mode related file, which cannot be opened in a text mode. So we will see certain examples of these modes in our Jupyter notebook when we will run certain examples on a sample file. Now, what is the file handling process, right? So in a plain vanilla process, first, of course, you will create a file and then you will open a file, update and close the file. So the first thing which you can do, but from the function standpoint, like we saw in our previous slide, even if you have to create a file, you have to call the function open, then you have to read it, you write in it, and then you close it. First thing which you have to then do in order to interact with the file is always make a call to the open function, and then you pass the file name and the mode as a parameter. Now, as we discussed, there are two modes. There are two types of files in Python, text file and binary file. So in text file, the data is stored in characters and string, and in binary file, the data is stored in the form of bytes. But the bytes file which you store, you can store in a different extension, and it can be read by other utilities or tools or softwares which are meant for reading the binary files. But you can interact or you can perform certain functions using the Python operators and the open functions which are available. Text file is a simple concept. You open the file, you can write, append, update the data, and you can open the file in your operating system and see your changes. So we are going to perform our examples on a text file where we will show you how you can view your changes by opening a file real time. Now there are some preliminary advantages, basic advantages of using files. This data is stored and is permanent. Basically, it resides in the file, and then it is up to you how do you save the data in the file in the operating system, or you persist that data in some secure area, and that is up to you. And the stored data can be shared. Definitely, you can mail the data, you can share it in a hard drive, you can share it on a network drive, etc. and you can update the data in the file. So you can append, you can override, you can remove, you can delete the file, all those operations, all those possibilities are there. So now let's create our Jupyter notebook with certain examples. So what I have done here is I have already created certain sample files where I have some predefined context there. So I have a Simplilearn.txt file in which I have written today is Thursday in one line, tomorrow is Friday, and I am waiting for weekend. Now I'm going to read this file. So I'll import the package in order to read the file. I'll create the file object. Now in this, I have given the path where my file is residing, today.txt. The same content is there. And I'm going to be opening it in the read mode. Though it's the default mode, but I'm calling it out explicitly for a better understanding. Now, this is the read command, file.read. This operator, this will read the entire file. So if you see in my file, all the contents are printed. Now, if I want to read the first 7 characters of my file, so what will this do? It will read the first 7 characters of the first line of my file. So in the first command, my file.read printed all the contents, but here I have passed a parameter to the read function to print only the first character, 7 characters. So that's what it has done. Now I will ask my function to read line by line. So now what is the difference between this and this? The difference is that the file.read read the entire file in one go, but here it is allowing me to read only one line at a time. Okay. So this function of read line will only go and read the line. Now, if I have to read all lines one by one, right? Now, here I have printed one line. Now I want to print all lines one by one. Then there is a different function which is file.readLines, and it will print an array, and of course you can see there's a /n operator because it's a different line. So it will print my 3 different lines in an array. Today is Thursday, tomorrow is Friday, and I'm waiting for weekend. Now, like I gave this example of file.read 7 characters, in the similar fashion, I can also provide how many characters to read from the line. Correct? So from the first line, it has given me the first 3 characters, and here in the file.read, it was starting to read the entire file, but I only limited to the 7 characters. Now let's take a look at the write function, write method. So now in my today.txt file, I'll now pass the mode W and I'll override it with my new content, which is the Sunday and Monday, and say file.close and run it. Now I can go and check it's being overridden. Now I'm going to create a new file. Let me create a new file and add contents to that. I'll create Simplilearn2.txt and run, and a new file has got created with the content sunshine. So here I have passed the mode as X. Now I want to delete a file. I will just simply pass os.remove. There is no open function to be called, and just give the name of the file, and my today.txt file is gone. Even I can put a check before removing a file whether the file exists or not. If it exists, then remove, else print that the file does not exist. There is no file. Now if I want to print line by line, I'll show you another example. If I want to print line by line, then the example is import and file dot in the loop, and you print the output. So basically you can, if you want to print the lines in a loop, then you need to put the for command, for loop, and put the read lines call.
We will discuss what is sorting in Python, what is the importance of sorting. We will discuss different sorting algorithms like bubble sort, insertion sort, merge sort, and quick sort with examples. What is sorting? Sorting refers to arranging available data in a particular format. So typically, when you have data in a non-sorted order, generally there is a requirement in any algorithm where you would require the data to be organized either in ascending or descending order. So if you take an example which is there available on the presentation, here you have a list L1 where you have random numbers which are unsorted, and then you have a sorted array which is in descending order, means highest number first and the lowest later. So generally any algorithm which you implement for sorting provides you a organized sorted list either in descending or ascending order. Now, why is sorting important? Now, you must have seen practically in your day-to-day life, whenever you are navigating through a website or through an application, you generally tend to, or you want to see data in a sorted order, either alphabetically or numerically. It makes search faster and easier, right? It becomes easy to search an item when if it is sorted alphabetically. Sorting is also used to represent data in more readable format. So it allows you to read the data which is sorted easily. It helps locate various patterns in the data. So for example, if you have an alphabetically sorted data, then you can easily compare if there is a difference in pattern in the data which is lying in an Excel sheet or which is shared with you in any other data format. Also, and another important point is duplicate values. you can easily find out if there is an occurrence of a duplicate value when the data is provided to you in a sorted fashion. So all the basic utilities, standalone utilities, applications like Microsoft Excel or other utilities provide you basic functionality of sorting of data alphabetically or numerically. Now, Python has a built-in sorting method which is called as sorted, and it gives you a data in ascending order. Whatever input you provide, the list, it will give you data in ascending order. And Python uses a time series sorting algorithm inbuilt to perform this sorting. So let's take a look of the inbuilt sorting algorithm which we are going to show you on my Jupyter notebook. So it's going to be very straightforward. What we are going to do is we're going to create a list and just invoke the list.sort method and print it. And just with one line of function call, our list is sorted in ascending order 12, 15, 27, 33, 62. Now with this inbuilt function, if you want to change the sorting order, right, you want to reverse it in descending order, you just have to pass a parameter saying reverse equal to 2 true and print the list. So if you observe, now you have your output in the descending order. So this is an inbuilt function, the sorted method, but we are here to discuss custom sorting algorithm, and we will start with bubble sort. Now, what is bubble sort? In bubble sort algorithm, the first element is compared with the adjacent element, and if the adjacent element is smaller than the first element, the elements are swapped. Basically, bubble sort is a sorting algorithm that compares two adjacent elements and swaps them until they are not in the intended order. So just like the movement of air bubbles in the water that rise up to the surface, each element of the array move to the end in each iteration. Therefore, it is called a bubble sort. It is the simplest sorting algorithm that works by repeatedly swapping the adjacent elements if they are in wrong order. So we have to remember the point that the elements in the array are swapped till the time the intended order is reached and each element has reached to the last iteration. So we will see this with an example. Now here you have a sample list which has unsorted data 9864. Now according to the bubble sort algorithm, what it will do is first it will start from the 0th element and compare it with its next adjacent element 8. Now in this scenario 8 is smaller than 9, so therefore we will swap it. So 8 and 9 will get swapped and now you have 8964. Now again 9 will be compared with its adjacent 6 and now 6 is smaller than 9, it will be swapped. Coming down, 9 now compared with 4, 4 is smaller than 9, it will be swapped. So till this point what has happened is 9 has been compared and with each of its adjacent element, and in this iteration now 9 is at its correct place, it's at its last place. Now we don't need to go to this iteration again, we will only go till the second last iteration. So now we will start from the beginning, we will compare 8 with 6, okay, and 6 is smaller than 8, we will swap. So now your output is 6849. Again 8 is compared with 4, 4 is smaller than 8, it is swapped. Now we will not go further because now we know 9 is at its correct position, 8 is at its correct position. Now only we need to do one iteration of comparison between 6 and 4. Now 4 is less than 6, we swap, and this is the final output of 4, 6, 8, 9. So all the iterations depend on the size of the list, but in bubble sort, the whole goal is that you keep it iterating till the time each and every element is compared with its adjacent element. Now, let's write a piece of code in Jupyter in order to compare our algo what we have discussed. Okay, so what I'll do is I'll just create a list of elements. Now, this is the list which I showed in my example, and I want to sort it. So I'll create a function bubble sort, and I'll capture the length of the array. Now I need two loops. One loop which will run n number of times the length of the array. So I'll create a loop. Okay. And then there will be a second iteration which will run from the first element of the array to the last element. Okay. One less than the last element till the time I have placed my sorted last element in the array. So I'll show you that. Now, in my example, I'll print my j iterator and the adjacent element to it. Okay. Now, what we have to do is we just have to write now the condition that if the element to which my inner loop is pointing is greater than the next element, then we will swap. Now in Python, there is a very easy way to write the swap code. You are swapping the two adjacent elements with each other. So you just have to write this line. And now this piece of code will place at j position the adjacent element of j plus 1, and at the adjacent element it will put the previous element. Now just to show you, I'll print the array at unsorted and sorted level. So I'll print the array over here and here so that you can easily understand how the array has been sorted. Okay, so now you have a one loop which is running for the number of times the length of the array, and then the inner loop which is running from every time from the first element to the one less element length. Okay, now let me run this. Okay, okay, so now what we have done is, now I'll explain my example. Okay, so what we have done is we have 9864. Okay, now the length of this array is 1 2 3 4. So the element, the length will be n, will be 4. My outer loop will run from 0 to 4, from 4 times 1 2 3 4, and now my inner loop j will run 6 times, and I'll show you how. So now first j at 0 and its adjacent element is at 1. So what we are doing is we are comparing 9 with 8, and 8 is smaller than 9, 9 is greater than 8, we are swapping it. So now this is my unsorted array and this is my sorted array. So 9 and 8 are swapped. You have 8, 9, 6, 4. Now I move ahead. J is incremented to 1 and the adjacent element is incremented to 2. So now I am comparing 9 with 6. As 6 is smaller than 9, I swap it. So now my next set or array is 8, 6, 9, 4. Now I go to J2 and adjacent 3. So J9 and 4. I compare 9 and 4. 4 is smaller than 9. I swap it. Now till this iteration now 9 has reached its correct position. Now I'll go back again and start my iteration from J0 back again and go only till this element 4. So again I am comparing 8 with 6. 6 is smaller. I swap. Then now I am comparing 8 with 4. 4 is smaller. I swap. Now 8 has reached its correct position. Again now I am going back to 0 and will only go to the point of 4. I compare 6 and 4. 4 is smaller and I get my sorted list of 4, 6, 8, 9. Now if you observe, the number of iterations which have happened are 1, 2, 3, 4, 5, 6. It's because 9 has traversed 3 times, 8 has traversed 2 times and 6 has traversed 1 time. 3 plus 2 plus 1, 6 iterations. So that's how you get those iterations. So this was an example of bubble sort. Now let's take example of insertion sort. Now what is insertion sort? Let's talk about that. Insertion sort places a given element at the right position in a sorted list. So in the beginning, we compare the first two elements and sort them by comparing them. Now let me show you what I mean by insertion sort. Now in insertion sort, whatever list you have, the first element is always considered to be sorted and the rest of the other elements are assumed to be unsorted. So you start your comparison of first element with its adjacent element, right? Now just to simplify things, insertion sort is like playing cards, where like you shuffle the cards and sort your cards, playing cards in your hand. It's just like that. Okay, so the array is virtually split into sorted and unsorted parts. Values from the unsorted parts are picked and placed at the correct position in the sorted part. So now in our example, our sorted part is 8 and unsorted is 4, 6 and 9. Now in the second iteration, we will compare 4 with 8. Now 4 is smaller than 8. We will put it before 8 and now we have sorted list of 4 and 8 and unsorted list of 6 and 9. Now in the next iteration, we will compare 6 with 8. Okay, and if 6 is smaller than 8, we will insert it before 8. And also we will compare 6 with 4, but now 6 is greater than 4, we will not swap it. Now my list is 4, 6, 8, 9 and 4, 6, 8 is sorted and 9 is unsorted. Now again I'll compare 9 with 8 and it's already greater than 8. I don't need to swap it and I'll not go any further and I'll stop it over here. So that's how my sorted list will get created. So my final list is 4, 6, 8, 9 and we'll see that with an example. So now let's create our insertion sort logic. So in my example, I want to create an array 8, 4, 6, 9, 15, 12. And I want to create a function called insertion sort. Okay. Now it's pretty simple. You want to traverse through the entire length of the array, but you want to start from element 1, not from 0, because 8 is your sorted element. You are already considering it your sorted element. Now take a variable in which you capture the outer array, and now I'm putting a while loop with two conditions. One is definitely the one which I explained, that you compare the unsorted element with the sorted element, so the previous element, and you go till the point on the sorted side till the last element. You don't need to go beyond 0, right? You need to only traverse through the first element, which is as the 0th index. And if you then you of course put the swapping code, you swap the unsorted element with the sorted side, and you need to go. So from the right hand side, you are going towards the left hand side of the array, right? From right towards left. So that's why you need to decrease the number. Okay. So what are we doing over here? What we are doing is we are comparing 4 to with 8. Now if 8 is greater than 4, you swap, and you only go till the point you have index 0. Okay. Like now if 4 and 8 will get swapped, now 6 will come. 6 will compare itself with 8. It is smaller, it will swap. 6 will compare itself with 4, and it will stop over there. So let me show you. I'll put a print command so that it is easy to understand. So let me print the array over here and see. Okay, so what I've done is I have to print my array. Okay, so this is my original array 8, 4, 6, 9, 15, 12, 11. Now in first time I compare 4 with 8 and swap it. Then I compare 6 with 8, it's smaller, I swap it, but 6, and also compare 6 with 4, I don't swap it. Then I compare 9 with 8, it is not small, I don't swap it and I stop it over there. Then I compare 12 with 9, it is not small, I stop it over there. Then I compare 11 with 12, it is small, I swap it, right? And then of course 15, I compare with 12, I stop it because it's already bigger. So it is like you divide, you always follow the approach of sorted and unsorted like I presented, and you keep comparing with the unsorted side element with the sorted side element and keep moving towards the left hand side. So now let's discuss another sorting algorithm called merge sort. Now merge sort is a divide and conquer algorithm. So basically in merge sort, you first divide the list into equal parts and then sort the parts and unite them as a sorted list. So basically you split the list into halves and then keep halving them, reducing each half till the time there is a single element in each half, and then you start merging them back in a sorted fashion. So we will discuss this with an example over here. Now for an example, we have our list over here with unsorted numbers 8, 4, 6 and 9. Now as it is even number of items in this list, so they will get distributed into two equal halves. In the left half you have 8 and 4, and in the right half you have 6 and 9. Now again recursively you will split each half, the left half and the right half again, till the time you have single elements. So now you see 8 and 4 now again get split into individual element of 8, 4 and 6 and 9 into 6 and 9. Now you start merging the individual elements in a sorted fashion. So first you will compare 8 and 4. Now 4 is less than 8, so you swap
and put 4 first and 8 at the second position. Similarly, when you compare 6 and 9, 9 is greater than 6, then the order of this particular set remains as is. 6 and 9 are taken into the new array. Now you have two merged halves which are in sorted order, 4 and 8 and 6 and 9. Now, while merging, you compare the leftmost elements of each array. So first you will compare 4 and 6. So 4 and 6, now 6 is greater than 4. You place 4 and 6 at their correct positions. Now you compare now 8 with 9. Now 8 is the leftmost item in the array and 9 is the leftmost item in its own array, and both are in the sorted fashion. So that's why you put 8 and 9 at their relevant position, and this is your sorted output. So definitely we will take a look at the example with our implementation in Jupyter Notebook. Okay, so now let me take my list example which I had shown in the presentation, and I want to perform a merge sort on this list. Okay, so I'll create a function merge sort, and I'll start off with checking that the length of my list is greater than 1. If it is a single element, then I don't need any sorting. Now I'll find the midpoint of my list and take the left part of the array list and the right part of the list. So the convention which I am using is actually automatically taking, means that the list starts from 0 till the midpoint, and the list here will start from midpoint to the length of my list. It's the same convention. So you can keep 0 or not, it's up to you. And the length of my list, I have the /2 means that if the list is of odd number, then it will divide by 2 and round it up to the nearest integer. So you will not get a decimal output. So you will get a integer rounded mid value. Now after I have done this, I will recursively call the left array and the right array into this merge sort. So using this, I'll be able to get the split value of 8, 4, 6, 9, and with this recursions I will reach to the point where I'll get individual elements of 8, 4, 6 and 9. Okay. Now I have to iterate through the left array and the right array. So I'll create two variables which will help me iterate through left and right array, and I am also initializing a variable which I'll keep as a counter for populating a new array which will comprise of my merged list. Okay. So now this is the logic. I will loop from left element from 0th index to the length of the left array and 0th index to the length of the right array, and I'll compare. If the left is less than equal to the right, it means I already have my value in the sorted order. I'll just add it to my merged array and put it at the kth position and increment my left array further. Else I have to pick up the right array element. So if the left array is smaller and greater than right array, then I put it the left one in the merged list, or if the right one is smaller than the left one, then I put it in the merge list and increment my right list. Now, while after this conditions are done, I increment my merged list incrementer. Okay, I move ahead. Now, there could be a possibility that there might be some elements which might remain uncompared in the left list. Like, for example, if this would have been an odd number of elements, then here would have been 3 and 2, then one element will remain uncompared. So then I need to iterate through the remaining left array and just put them in my merge list and increment I and k by 1. And same could be the possibility of the right array, that there might be some elements which might remain uncompared or unsorted in the right array. So I'll put them back in my merge list. So my list is my list which I am updating constantly. So now let me put some prints. When I'll run this code, I want to put some printouts so that I can explain where my list is. Now this is my merge sort and I'm gonna run this. Okay, so now what I have done, we had a list of 8, 4, 9, 6. So in the first recursion, the list got split into 8 and 4 and 9 and 6. Okay. Now, okay, sorry, let me just make it similar. 8, 4 and 6, 9. Then in the second recursion, I have 8 as a single element, 4 as a single element, and in the third recursion I have 6 as a single element and 9 as a single element. Now after that, this logic gets executed where I compare left and right elements and I merge them. Okay, so now I compare 4 with 8 and 4 is less than 8. I swap it, move 4 to the left common array and then 8. Then in this case 6 and 9, they're already in the sorted fashion. I just move it into my common list, my list. And again now 4, 8 and 6 and 9 are compared. The leftmost element is 4 compared with 6. It's smaller. It is put it in the common list. 8 and 9 are smaller. It is put it in the common list and you have the sorted array. So this is the idea behind a merge sort, where you have divided the list to the nth element, to the 0th element, and then you start merging it back by comparing the leftmost elements. Now let's take an example of another sorting algorithm called quicksort. Quicksort, like merge sort, is also a divide and conquer algorithm, but in a different way. In quicksort, first you choose a pivot element in the array, then store elements less than the pivot in the left subarray and greater than the pivot in the right subarray, and then keep doing this activity recursively for each subsequent left and right array which you have done. After that, we will call quicksort on the left subarray, and similarly we will call quicksort on the right subarray. So it's a recursive algorithm based on the choice of the pivot element which you have taken on the array. Generally, the pivot element is generally taken as the rightmost element of the array. Now let me try to explain quicksort with an example over here, and then we will look into the Python code. Now I have an array with 6 elements where my last element is my pivot. So now what I have to do is I have to create a left array where all the elements smaller than 34 should get aligned, and then I have to create a right array which should be having elements greater than 34. So in order to achieve that, that is the whole algorithm which you have to write. Now I have taken two pointers, the orange colors, and the one on the left hand side and one on the right hand side. This is I and this is J. Now what is the job of I pointer? The job of I pointer is to find the elements which are less than 34, and the J pointer is to find the elements which are greater than 34. Okay, so I will keep on shifting towards the right until and unless it finds an element greater than 34, and in case of J element it will shift towards the left until and unless it finds an element less than 34. Okay, so we will see that. Now I will start its journey from the 0th element always, and J will start its journey from the one element less than the pivot always. Okay, now in this example I is already pointing to a element which is greater than 34, but J is pointing to an element which is greater than 34, but it should move towards the element which is less than 34. So now I will remain static and J will move one element further, which is 17, and it will check whether J is less than 34 or not. If not, then it will stop over here, correct? And I is less than a pivot or not. If not, then it will also stop over here. Okay, so J will check if it is greater than 34 or not, and I will check if it is greater than 34 or not. Now in this scenario, 40 and 17 now are meeting the condition that whether 40 is greater than 34 and 17 is less than 34, we will make a swap of these elements. So 17 will interchange with 40 and 40 will interchange with 17, and then now I and J will continue their journey ahead. What will happen now? I moves to 21, J is at 40. Okay, now 21 is less than 34, I will continue further. It will come to 8. Okay, 8 is also less than 34. I has now moved to 40, right? Now 40 is not less than 34. I will stop over here. Now J, what happened with J? J is greater than 34. It will move further. Now J has reached 8 and I has reached 40. Now at this point, when J has crossed I, then now it is the point when you need to swap the pivots. You need to change the pivot. So at this point, when J has crossed, when J is greater than I, you need to swap the pivots. So in this case, what will happen is 40 will get swapped with 34 and 34 will come in place of 40 and 40 will go to the end. Now with this whole exercise, what has happened now, 34 has found its correct position in this entire array, and if you monitor, all the elements on the left hand side of 34 are smaller to 34 and all the elements on the right hand side are greater than 34, and this is what we wanted to achieve. Now the same logic will get applied to left array and right array. In left array now 8 will be assumed as the pivot, and in the right array 40 will be taken as the pivot. Now, and applying the same logic, now 8 is taken as the pivot, 17 and 21 I and J are pointing. Now as there are only two elements, 21 is greater than 8, 17 is also greater than 8. So then automatically 21 will move ahead, J will move ahead and I will move ahead, and then 21 and 17 will swap each other. So the final will become 8, 17, 21. Here we only have one element of 51. Okay, 51 and 40 will swap amongst themselves as pivot and they will align themselves. So I know it's a little confusing and a complicated algorithm, but I'll try to explain this with my example. Now what I have to do is I have to create my data, and I am creating a quick sort algorithm. Now, in order to start the quick sort, I need to send the 0th index and the length of the array -1. And of course, if the length of left is less than right, means there is some data, then only I'll continue. Now, secondly, what I have to do is I have to find the index of the pivot element and pass it recursively to the quick sort. So now we will create another function which is called partition, which will encapsulate the entire logic. So I'll create my left pointer I, which I was explaining, the right pointer j, which is one less than the rightmost element, which is my pivot, and I'll capture my pivot, which is the rightmost element in our example 34, and then I'll run a while loop for the duration when while I is less than j, right? When j becomes greater than less than I, means when they cross the path, then we will swap the pivot. Now first I will move my left iterator I to the right hand side, right, when it is less than the right, and I'll check my element on the ith index is less than the pivot, because this is my left subarray, and then I'll increment. Similarly, I will move my j iterator from right to left, compare that the element at the j pointer is greater than the pivot. So because I have to create my right subarray. Okay. Now I am checking if my I index is less than j, correct? Then I'll swap the elements, and let me print the array over here. Now outside the while loop, I'll check my array I index is greater than the pivot. Yes. Then I am now changing my pivot, basically pivot value. I'm swapping the pivot value, and I'll print it here for you, and I'll return the I. This is the index of the pivot. Let me indent it correctly and print it. Okay, let's see what has happened. Now this is my original array where the pivot is starting from 34. Now, as I told, my I did not move ahead because I is checking if my element of I is less than pivot. 40 is greater 40, so I has not moved, but j moved. J moved from started from 51 till 71 till 17, and it stopped over here. and at this point 17 and 40 got swapped. 17 came over here and 40 came over here. Now hereafter I started moving forward. 21 is less than 34, okay. 8 is less than 34, okay. 40 is less than 34, no. So I stopped over here. My J was at 40, it moved further. 8 is greater than 34, no. So I and J have crossed each other. Now this is the point where we have to make a swap between 40 and 34. Okay, so 40 will move to the end and 34 will come in middle. So now 34 has reached its desired and actual position, and all elements left of 34 are smaller than it and right of 34 are greater than it. Now I am working on my left subarray where 8 is my pivot. Now I will start from here. So 17, it is greater than 8, it will not move ahead. 21, it is greater than 8, it moved ahead. J, and it reached 17. Now 17 and 21, now J has crossed I, they will swap each other, okay. And now my array position is 8, 21, 17, 34, 51, 40. Now my pivot changes to 17. 17 will be compared to 21, and this is the swap happening over here. Now coming to the right subarray, my pivot is 40, only single element is there, 40 and 51. The swap will happen over here. So as you understand, quick sort, you will better understand when you run it with multiple examples.
Video, we are going to perform a really interesting data analysis using Python on the Spotify music streaming service platform dataset. I'll also be asking you a few questions related to Spotify during our discussion. Please make sure to answer them in the comment section of the video. So now let's get started. Spotify is a Swedish audio streaming and media services provider founded in April 2006. It is the world's largest music streaming service provider and has over 381 million monthly active users, which also includes 172 million paid subscribers. The total number of downloads on the Spotify app in the Android store exceeded 1 billion in May 2021. So millions of people listen to music all day. Even I am hooked to music. As an analyst, what's better than exploring and quantifying data about music and drawing valuable insights? Before I move ahead, I have a quiz question for you people. The name Spotify comes from a combination of two words. So which are those two words? Please let us know your thoughts in the comment section below. I would like to repeat the question again. The name Spotify comes from a combination of two words. So what are those two words? We would love to hear from you. So please put your answers in the comment section below. Now let's use Python libraries and functions to analyze and visualize our dataset. First, I'll show you the two datasets that we'll be using. So here is the first dataset that we'll be using for our demo, and then I have my second dataset called Spotify features, which is essentially about the genres of the different soundtracks. Now these datasets have been downloaded from kaggle.com. Now the links to the datasets have been provided in the description box. Please go ahead and download them. Now let me just go ahead and brief you about the columns that are present in our first dataset, which is about tracks. We have our column A, which is ID. This is the unique ID for each of the songs. Then we have the name column, which is essentially the name of the song. Then we have a column for popularity. So the popularity ranges from 0 to 100. Then we have duration in milliseconds. This is the duration of the track in milliseconds. Next we have a column called explicit. Now we are not bothered about this column because we are not going to use it in our analysis. Then we have artist. So the name of the artist who has composed or sung the song. Then we have ID of the artist. Then we have a column for release date, which is basically the date on which the song was released. Then we have a column for danceability. So this describes how suitable a track is for dancing based on a combination of musical elements such as tempo, rhythm stability, beat, strength, and overall regularity. The value ranges between 0 and 1. Next, we have a column for energy. So the energy is a measure between 0.0 to 1.0 and represents a perceptual measure of intensity and activity. Typically, the energetic tracks feel fast, loud, and noisy. Higher the value, the more energetic is the song. Then we have a column for key. So key is the pitch, notes or scale of song that forms the basis of a song. There are 12 keys ranging from 0 to 11. Moving ahead, we have loudness. So the overall loudness of the track in decibels, it ranges from -60 to 0 decibels. Then we have mode. So songs can be classified as major and minor. 1.0 represents major, or 1 represents major, and 0 represents minor. Next, we have speechiness. So speechiness recognizes the presence of spoken words in a track. More exclusive speech like the recording, example talk show, audiobook, or poetry, the closer to 1.0 the attribute value. Then we have a column for acousticness. So a confidence measure of 0 to 1 of whether the track is acoustic or not. So 1.0 represents high confidence the track is acoustic. Then we have other information about instrumentalness. Then we also have a column for liveness. So liveness detects the presence of an audience in the recording. Then we have a column for valence. So valence is a measure between 0.0 to 1.0 and describes the musical positiveness conveyed by a track or a song. And finally, we have the columns for tempo and time signature. Now, even in the second data set, we have almost the same columns, just that we have an additional column that is about the genre of the songs present in the data set. Cool. Now let's head over to our Jupyter notebook and we'll start with our analysis. Okay, so one more thing to remember. Our data has information from 1922 onwards. So all the songs from 1922 till 2021. Cool. Okay, so I'm on my Jupyter notebook. So you can see I have a few cells that have already been filled up. So we'll start with our analysis. First of all, let's go ahead and import the necessary libraries. So I'm importing NumPy, Pandas, Matplotlib, and Seaborn for my analysis and visualization. I'll hit Shift Enter to import the libraries. Alright. And in the next cell, I'm going to load my dataset using the pandas read_csv function. I have my location already put here. Let me show you the location where the data files or the data sets are located. So this is my location. Under Chrome downloads, I have a folder called Spotify datasets. Okay, so let's import and check the first 5 rows in the dataset. So for that, I have used the head function. There you go. So here you can see I have my first 5 rows of information from the dataset. And on the top, you can see the different columns. You have ID, name, popularity, artist. Then we have the release date, danceability, energy, key, loudness, liveliness or liveness, valence, tempo, and other information. Cool. Now, let's check for null values in the dataset. I'll just give a comment as null values. Every time when you download a dataset from an open repository, there are chances that the dataset would contain null values. So it's better to check them beforehand. So I'm going to use the isNull function present in the pandas library. PD I'm using because I had imported pandas as PD. So pd.isNull. Then I'm going to use the variable name df_tracks because I imported my dataset and stored it in the variable df_tracks. So I have my data frame under df_tracks variable, and then I'll use the sum function to check the total number of null values present in the dataset for each of the columns. If I run it, there you go. So here you can see my name column has 71 missing values or null values, and we don't have any null values for the rest of the columns. Okay. Now let's use the info method that will give us the total number of rows and columns in the dataset, and we'll also check the data types and the memory usage. So I'll say my data frame name, that is df_tracks.info. If I run it, you can see here, now if you mark, there are total 5,86,601 names, or the names of the songs present in the dataset, while the rest all have 5,86,672. So clearly there are total 71 song names or soundtracks missing from our dataset. And below you can see the data types. We have float, integer and object, and then you can see the memory usage. Cool. Now before I move ahead with our next analysis, I have another question for you. Which artist or musician has the most number of followers on Spotify? I repeat, which artist or musician has the most number of followers on Spotify? Please put your answers in the comment section below. We would be happy to hear from you. Now let's move ahead and do our first major analysis in this demo. We are going to find the 10 least popular songs present in the Spotify dataset. So I'll create a variable called sorted_df that will be equal to my data frame name, that is df_tracks dot. I'm going to use the sort_values function and say my column name is popularity. So I'm going to sort the values based on the popularity and then say ascending equal to true, since I want only the least popular songs. And then I'm going to say head of 10, which means I want the top 10 least popular songs. Now let's go ahead and print sorted_df. If I run it, you can see we have the list of 10 least popular songs on Spotify. You can see that popularity is 0, and you can see the names of the songs. Some of them are songs which are not in English language, and you can see the artist names as well. Cool. Now moving ahead, let's see some descriptive statistics for the numerical variables that are present in our column. So I'll say df_tracks dot describe, which is the function to get some descriptive statistics, and I'm going to use the transpose function after that. If I run it, there you go. So we have the statistics about count, mean, standard deviation, minimum value, 25th percentile, 50th percentile, 75th percentile, and the maximum value for these columns like popularity, duration in milliseconds. Then we have energy, key, loudness, mode. Cool. Now if you see this popularity column, the minimum value is 0 and the maximum value is 100, and you can see the 50th percentile is 27, which is essentially the median. You have the standard deviation as 18.37. Then similarly you can check for the other features as well. Cool. Now we'll see the 10 most popular songs which are greater than 90. So we are going to check for the top 10 songs with popularity greater than 90. Let me show you how to do it. So in this cell, I'm going to create a new variable called most popular, and I'll say df_tracks dot. This time I'm going to use the query function that is part of pandas library again. I'll use the column that is popularity, and we'll set the condition popularity should be greater than 90. I'll give a comma and say in place equal to false, because I don't want to change my original data frame. and then I'll say sort underscore values, and I'm going to sort it based on popularity in descending order. So I'll say ascending equal to false, and then let's take only the top 10 popular songs. So I'll say most popular, use square brackets, and we'll then pass the slicing operator and say :10. Now if I run this, there you go. So here you can see the 10 most popular songs that is present in our Spotify dataset. So first we have Peaches by Justin Bieber, Daniel Caesar and Giveon. Then we also have a song name called Driver's License, Astronaut in the Ocean, Save Your Tears. We also have The Business, Streets, and Heartbreak Anniversary. So these are the most popular songs that are present in our dataset based on their popularity. You can see Peaches has the highest popularity with 100. Alright, now moving to the next cell. So here we are going to set the index to be release date column in the main data frame. So I am setting my index using the set underscore index function. I have passed in my column name as release date, and I'm saying in place equal to true, which means I want to change it in my original data frame, and then I'm changing the value to date time format, and let's print the head of the dataset. So you can see here we have successfully changed our index. Now here you can see instead of 0, 1, 2, 3 we have the release date column, and the rest of the columns are intact. Cool. Now let's move ahead. So suppose you want to check the artist at the 18th row in our dataset. You can use the index location method for that. Let me show you how to filter only specific rows of information from the dataset. I'll use my data frame df underscore tracks, and using double square brackets I'll say my column name, which is artists, and I'll use the index location method and say, let's say I want to check the artist who is present in the 18th row in my dataset. So I'll use iloc18. If I run it, the artist's name is Victor Boucher. Cool. Now let's move ahead. We are going to convert the duration in milliseconds to just seconds. So if you see our dataset, we have a column called duration in milliseconds. So all our songs are present in milliseconds. Let's convert them into just seconds. So for that, I'm using the lambda function and dividing the values in milliseconds by 1000 so that they get converted into just seconds. I have used in place equal to true, so I want to change it in my original data frame. Let's run it and do the necessary changes. Alright, now we'll print the head of the dataset just to check the duration column. So I'll say df underscore tracks dot duration dot head. If I run it, there you go. So you can see the values have now been changed to just seconds. Cool. I have the final quiz question for you. Who has the most monthly listeners on Spotify? Please put your answers in the comment section below. We'd be glad to hear from you. Now coming to the next cell. So here we are going to create a first visualization that is going to be a correlation map. We are going to drop 3 unwanted columns, and those are key, mode and explicit, and then we are going to apply Pearson correlation method. Now I have set my figure size to 14,6, and then we are using the Seaborn heat map function to create our correlation map. I have put the variable that is correlation underscore df. You can see above we had created this, and then I'm setting annotation equal to true. So this will write the data value in each cell. I have set fmt equal to .1g. So this is a string formatting code to use when adding annotations. Then I have set my vmin and vmax. So these are the values to anchor the color map. Otherwise they are inferred from the data and other keyword arguments. CMap here stands for color map. You can just search for SNS CMap. You will get the documentation. So you can choose whichever color palette or the color map you want. Here I have used Inferno, and I have set my line widths and line color. Finally, I am giving a title to my correlation map, and I have set the X-tick labels. Let's go ahead and run this to get our first visualization. If I scroll down, there you go. We have got a nice correlation map. So here on the right side you can see the scale. It ranges from -1 to +1. -1 means the variables have least or negative correlation, while the values which are above 0.0 means that the variables have a positive correlation. Now here you can see there are values like -0.7 for energy and acousticness, which means if the energy is high, the acousticness is really low. Again, for loudness and say speechiness, if the song is loud, the speechiness is low, so there is negative correlation. But if you see for energy and loudness, there is really high correlation between these two variables. You can see the value is 0.8. So if the song is loud, this implies the song has really high energy, and vice versa. Now if you see for a few other variables, there is negative correlation between acousticness and danceability. There is negative correlation again between valence and acousticness. Similarly, there is positive correlation between energy and valence, which is 0.4, and even for danceability and valence there is positive correlation, which is 0.5. Cool. So from the correlation heat map you can note that acousticness appears to have a strong negative correlation with energy. So if you see for acousticness and energy, there is a strong negative correlation, and there is a moderately strong positive relation between loudness and popularity. So if you see for popularity and loudness, the color is orange, which means it lies in this positive region. And there is also a moderately strong positive relation between danceability and valence. So if you check for danceability and valence here, there is a moderately strong positive correlation. Alright, now let's move ahead. We are going to sample our data and take just 0.4% of the total data, and we'll create 2 regression plots using this data. So let me first sample my data. So I'll create a sample data frame using my original data frame, which is df_tracks, and say sample. I'm going to use the int function and say 0.004 multiplied by the length of my original data frame, which is df_tracks. Alright, now let's run this and we'll print the length of my sample data frame. If I run it, you can see 0.4% of my total data set is 2346 rows. Cool. Now we are going to create a regression plot between loudness and energy. Now in our correlation map, we saw there was a positive correlation between loudness and energy, which was 0.8. Let's plot it in the form of a regression line. So I'll use plt dot figure. I'll set my figure size equal to, let's say, 10,6. I'll say SNS dot regression plot. So I'm using the function called reg plot, and I'll use my data as sample underscore tf, give a comma, and say in my y-axis I'll have my column loudness, and in the x-axis we'll have energy. I'll give a color to my data variable. Let's say the color is C. Then I'll set my title to loudness versus energy. Let's say correlation. Alright. Let's make sure everything is fine. Now we'll run and see our result. There you go. So you can see here clearly there is a very high positive correlation between loudness and energy. On the y-axis we have loudness, and on the x-axis we have energy, and you can see all the data points or the songs are in one direction. So if the energy increases, the loudness of the song also increases, and similarly if the loudness of the song decreases, your energy of the song or the track also decreases. So there is a very high positive correlation, and you can see the regression line here. It has gone and is increasing gradually. Cool. Now similarly, I'll just copy this code, and we are going to see another regression plot, this time for two different features. Let's say we have popularity in the y-axis. So I'll say popularity, and then in the x-axis we have, let's say, acousticness. I'll change the color to, let's say, B, which stands for blue, and will set the title to popularity versus, I'll have acousticness correlation. Just scroll down and we'll run it to see the result. There you go. So I have the different points for the songs, and here you can see the regression line is downwards, which means if the acousticness of the song increases, the popularity decreases, and similarly if the popularity increases, acousticness decreases. You can see the downward trend of the regression line. Alright. Now in the next cell we are going to create a new column called year from our release date column, and I have changed this to date time format. Let me just run it. Cool. Now after that we are going to create a distribution plot to visualize the total number of songs in each year since 1922 that is available on the Spotify streaming app. So I have used my Seaborn library and dist plot function. Now one thing to remember, you need to update your Seaborn library to this version if you haven't done it. So use this command pip install --user Seaborn and the version. So here in the distribution plot we are going to plot a histogram. So I have used kind equal to hist, which stands for histogram. Let's run and see the result. Okay, so here you can see I have my distribution plot. So the plot tells us that the Number of songs for each year in the dataset according to their release date have increased in the recent years since music became more accessible to people globally with technological advancements. So earlier you can see there were very few songs available in the 1920s. Later on the number of songs increased rapidly, and now you can see we have a lot more songs available for people to listen. Cool. Now we are going to see the duration of songs over the years. For that, again, we are going to create a bar plot. So I'll first create a variable called total duration equal to df underscore tracks dot. I'll use the duration column that we created with seconds, and then I'm going to set my figure dimensions. So I'll use figure underscore dims for dimensions equal to 18,7. After that, I'll have my figure axis defined. So I'll use the matplotlib subplots function, and I'll set the figure size equal to my figure dimensions, and then I'll say figure equal to sns dot. I'll use the bar plot function and say my x-axis to be years. My y-axis will be total duration or total underscore dr that we created here. I'll set my axis equal to ax, and then I'll set error width equal to false. Let's set the title for my plot as title equal to year versus duration, and finally I'll say plt dot xtix. I'll rotate it by, let's say, 90 degrees. Alright, let me just recheck once if everything is fine, and then we'll go ahead and run it. My axis, error width, title. Okay, let me just run it. We'll see the result in a moment. If I scroll down, you can see we have the bar plot for the different years and the duration of the songs in seconds in the y-axis. So earlier in the 1920s, you can see the duration of the songs were less, and later it increased around late 1930s, and this remained consistent until 2010, where the duration was high. But after 2010, you can see the duration of the songs have started decreasing. Now in the next cell, I'm going to create a line plot to analyze the average duration of the songs over the years. It is going to be similar to our bar plot, just that now we are going to visualize it in terms of a line. So I have my code ready. You can see here I've used my Seaborn library and the line plot function. In the x-axis I have years, and in the y-axis I have total duration. I've set my title to year versus duration, and I'm rotating my x labels by 60 degrees. Let's run it and we'll see the output. There you go. Now if I scroll down, you can see we have a nice line plot, and on the x-axis you have the years, and on the y-axis we have the duration. You can see that the songs from 1920s to 1960s have comparatively shorter duration. since most of the songs tended to be more singing based rather than instrument based. After 1960s, you can see the duration of the songs started increasing until I would say 2010, and in the present day the duration of the songs have started declining since the attention span of the average listener is also declining. Alright, now let's move to our second data analysis project, which is based on genres of the songs. So I'm importing my dataset using the pandas read_csv function. I have given my location, and here I have my dataset name followed by the extension of the type. So this is a CSV dataset. Let's go ahead and run it. Okay, now let's print the first 5 rows of the dataset. I have stored my dataset in a data frame called df_genre. I'll use the head function to get the first 5 rows of information. I'll hit shift enter to run it. There you go. You can see here I have my genre column, artist name, track ID, popularity, acousticness, duration in milliseconds again, and we have the rest of the other columns that we saw in our first dataset. Just one thing to note, here key is present in terms of C, D, E, C minor, F minor, and not in terms of numbers between 0 to 11. Now we'll see the duration of the songs for different genres. For that, I'm going to create a bar plot. So I'll start with setting the title for my plot as duration of the songs in different genres. I'll use the Seaborn library and I'll set my color palette to, let's say, rocket. I'll give a comma and say as CMap equal to true. This would be color palette. Now I'll say SNS dot bar plot. In the y-axis I'll have genre, and in the x-axis I'll have my duration column, which is in milliseconds, so duration underscore ms, and then I pass my data frame using the data argument. So I'll say data equal to df dot genre. Next we'll set the x labels, so I'll say plt dot x label. Let's say my x label is duration in milliseconds, and then I'll say plt dot y label as genres. Now let's go ahead and run this. There you go. So here you can see we have the different genres on the y-axis, and on the x-axis you have the duration in milliseconds. And if you see the graph for classical genre and for songs that belong to world genre, the duration of the songs are more compared to other genres. Now if you check for children's music genre, the duration is less or the least. Cool. And finally we'll move to our last demo where we'll see the top 5 genres by popularity. So I'll say SNS dot set underscore style, I'll set my style to dark grid, which will be my background, and then I'll say plt dot figure. I'll set my figure size to 10,5. Then I'll create a variable called famous, since I want to take only the most popular songs based on the genre. So I have created a variable called famous, and I'll pass my data frame name, that is df underscore genre, and I'll sort the values based on my popularity column. So I'll say popularity, and I want to sort it in descending order. So I'll say ascending equal to false, and I'll take the first 10 values. I'll tell you the reason why I'm taking the first 10 values and not 5. Then I'll say SNS dot bar plot, and in the y-axis I'll have genre, in the x-axis we'll have popularity, and I'll give a comma, and using the data argument I'll say my data to be famous, which is this variable that we created, and then I'll set my title as top 5 genres by popularity. Alright, now the reason why I took head of 10 is because there are a few genres which are repetitive. So if you see this, we have children's music appearing twice, so hence we have taken 10 instead of 5. Let me just go ahead and run it. There you go. So here if I scroll down, you can see I have my top 5 genres based on the popularity. So we have dance, pop, rap, hip hop and reggaeton. So these are the 5 genres which are most popular based on the data that we have collected from Spotify. Alright,